All right, 3.4 combinations and Pascal's triangle. All right, so I'm going to go through Pascal's triangle first. If you were in 11U, you took 11 University last year, then you should be okay with this. If you were from 11 Mixed, then you're probably going to struggle a little bit with it. Okay, but then we're going to introduce something new called binomial theorem. Okay, that's the formula here. So it's NCR, x to the power n minus r, and then y to the power of r as well. It's not that difficult, but I'm going to show you a different way to do expanding using binomial theorem as opposed to Pascal's triangle. All right, so here we go. This is, for some reason, got kind of skewed. Okay, so Pascal's triangle starts with a 1. Okay, this is row 0. So we start with a 1, and this is considered row 0. Then every row we go down, we're going to add 2 1s to the ends. So we have a 1 here, and we're going to add a 1 and a 1. And this is called row 1. Again, every row we're going to add 2 more 1s. What this row 0 means, it's a 0 degree. So anything to the power of 0 is 1. This is row 1, so it's degree 1. So like something that's linear, so x plus 1. Row 2 is something that's quadratic, and so on. Okay, so we're going to add, next row, we're going to add 1 to the ends. We call this row 2, because that's the quadratic line. Then we go next one, add 1s again, and we go row 3, which is the cubic line. Okay, but we're not just adding 1s. We actually have to start filling in the spaces here. So we start with 1 number, then 2 numbers, then 3 numbers, then 4 numbers. So we should be increasing numbers as we go along as well. So this has 1 number, this has 2 numbers, 1 and 1. This should have 3 numbers. So we have to fill in the middle. So there's going to be a middle number here. The way we fill it in is by adding the numbers above it diagonally. Okay, so diagonally above is 1 and 1. So we have an answer of 2. So 1 plus 1 is 2. So 1 number, 2 number, 3 number, row 3, we need 4 numbers here. So we need a number here and a number here. Again, we count the numbers above it diagonally. So 1 and 2 is 3. 1 and 2 is 3. Okay, we're going to go to row 5. So add 1s, and then add 1s again. And this goes infinitely, so 3, 4, 5, 6, all the way to an infinite number of solutions. But every time we're going to add more numbers. So this one has 4 numbers, so we need 5 numbers here. So we have 2 of them, so we need 3 more. And then this one means we need 4 more. So again, we go diagonal, so 1 plus 3 is 4. 3 and 3, so these 2 is 6. And then 3 and 1 is 4. So go diagonal. Then 1 and 4 is 5. 4 and 6 is 10. 6 and 4 is 10. 4 and 1 is 5. Okay, so we end up getting these rows and it keeps continuing. Okay, so the 1s are part of the row. So 1, you're going to need to know how to develop this yourself, by the way. So 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. Okay, you do not have to memorize the actual numbers, but just know how to get them. Okay, so that is Pascal's triangle. Okay, number 1, Mark rides his bike to school and travels 4 blocks west and 6 blocks north. Use 2 methods to determine the number of different routes Mark could take to school if he only travels north and west. Okay, so I'm going to draw this out here. I'm going going to show you the longer way and then the shorter way. So I'm going to be north, 6 north, 1, 2, 3, 4, 5, and 6. Go 1, 2, 3, 4. Okay, so these are, pretend that these are the blocks. So he starts, rides bike to school, so he gets started at home. And then school is over here. So he has 4 blocks west and 6 blocks north. Okay. Okay, so if we're at home, he could choose to go north first or west. So if he goes west, it's one way he could go. And if he goes north, it's one way he could go. Okay, so we're trying to get the number of ways or different routes he could go. Okay? But to get to this spot here, he could go west, then north, or north, then west. So to go here and here, it's 2 different options. So he has 2 different ways to get to this spot here. Zoom this in a little bit. Okay, if he keeps going west, this is just one way he could go. So we just keep adding ones here. Okay, and if he keeps going north, it's just one way. So it's just one way to get to each of these intersections or blocks. Okay, so now let's work with this one here. So if you go, he could go, so Mark could go here, up and across, that's one way. He could go this way, which is 2, and the other way is across, which is 3. Okay, so it would be 3 different ways he can get to this spot. But an easier way to find that out is just by adding the numbers that connect to that corner. So 1 and 2 gives you 3. Okay, same thing. To get to this spot, we add the 1 and the 3 gives us 4 different ways he can get to this intersection. And we continue. So 1 and 4 is 5. So there's 5 different ways to get to this one. So it'd be 1, 2, 3, 4, and 5. Okay, we're going to continue going this way. Again, he wants to get to this block here. He has 2 plus 1, which is 3 different ways to get there. And to get to this here, so 3 plus 3 is 6. Then we're going to continue the pattern. 4 and 6 is 10. 5 and 10 is 15. Keep going, I'm going to go faster. 3 and 1 is 4. 6 and 4 is 10. 10 and 10 is 20. 15 and 20 is 35. Okay, keep filling them in. So we get to school and we're at 210 ways. So if you do this, the final answer at that corner would be 210. So there's 210 ways that he could go from home to school. Okay, now I'm going to show you the second method, which is actually quite easy, but I would want you to do the map on a test. Okay, so in total, there's 10 blocks. So to get there, it would be 10 factorial. But each going west is like, if you're going west, there's 4 blocks going west, so we consider them like elements. So we divide by 4 factorial. Or he goes 6 blocks north, and we consider those like elements, so we divide by 6 factorial. And when you do that, you'll get the answer of 210 weights. Okay, that is question number 1. Okay, now question number 2.